Today on the Chaos Laboratory, we have the Witches Tower from Lemax. It doesn't work. According to the message that I got before it was shipped to me, is that it's shorting out the power supplies. So this is the standard, this is the older style, that's why it's so fat. 4.5 volt power supply. And if you plug it in a 3-headed power supply, it apparently is causing the other components that are plugged into the other heads to malfunction. Which indicates to me that this thing has a short. These power supplies are not protected. Least path of resistance, and that's why it kills the other two components on your 3-headed power supply, as an example. And then as far as the single head, if you kept it plugged in for long periods of time, you could technically burn out the power supply or cause a small fire inside here, which I have seen on a couple of pieces, and it makes it really difficult to repair because there are no spare parts for the electrical components. So I'm not going to use the factory power supply because, as I just mentioned, there's no protection. But my power supply, which I have hooked up here, has protection, which means if this is shorted, the power supply will trip internally, preventing any damage to it's the power supply, or this, the component. So my power supply is set for 4.5 volts. And we're going to plug this thing in. And my power supply went into protection. So there is definitely something wrong with this. So we're going to try and open up and find out. Now, just examining the piece, and I know this doesn't have the witches on the top, which is fine. I don't need those to see if it works or to fix it. On this piece, we have little access holes, not for fixing it, but just to see inside. Looking inside, I'm going to say it's a bad motor. It's going to be really hard to see, especially in the size of the hole. But there is an absorbent amount of grease in there. And the biggest cause I see for failure on most animated pieces is the motors fill with the grease, the lubrication, and it shorts them out because it conducts electricity. You can also look through the windows because you can see inside. And in the windows, you can see the wiring, hopefully. You can see it in there. And it's in there that goes up to the light that's up here. So, and probably the light that's right there on the back. So those who don't have this piece, there's a set of witches up here that spin in a circle. There's, I think, 3 of them. And this table here rotates around, which has tension. I'm not going to force it, but there is tension on it. So hopefully the mechanism that drives all of it is good. Like most of the Lemax, we're going to come in from the bottom. On the bottom is a rubber mat, and there's an indentation right here. You can see the edge of it right there, which should allow me to get to the mechanism that I can see through all those holes in the back. So you can try heating up the mat. I'm going to see if I can just get it up with a scraper to start. Spudger. So let's see what we can do here. I'm sure if I can just get the edges, we can pop the center out as one piece. But a lot of these mats, though, they're getting better adhesive on them, so they don't come off as easy. Let's see what we got. Let's see what's right. This is an X-Acto scraper blade. See if it'll work any better. I might have to just replace the mat with another mat. It won't say Lemax on the bottom. Alright, well, I'm going to work on getting this mat off, so I will be back in just a moment. You don't have to watch me for however long this is going to take. So we can try and reduce the length of these videos so they're not so long, just to get to the internals. Be right back. Alright, we're back. That was going pretty good, and then it tore, so I just scraped most of it off, so I'll have to replace the mat when we're done. There's a circle here with hot glue, and the mat was stuck right in here in the hot glue, so once I got it to start peeling, because you see it's nice and clean, it ripped. So I'll put a new mat on here. If you do have to take it off, be very careful. Right here, you have a set of wires for the light that's right there on the front. You'll want to cut those with a spudger or a scraper. Also, what's very interesting is this piece right here, sounds hollow, has the shape of like a battery door. I don't know if you can see it lifting when I press on it. So that's kind of interesting that it might have been a repurposed battery box. I guess we'll find out when we open it. See what or why this has a section. There is a slot right here. There's nothing over here under the rubber, and there's no other slots anywhere around it. There's a notch. So it almost looks like you could pry it open, but it doesn't budge. And I'm not going to try and break it. So I'm going to go ahead and remove the hot glue with a screwdriver first. If I can't get it to come out, then I will heat it with a heat gun. This whole base is plastic, so I'm going to try and do it this way first, so I don't have to worry about heating it up and then causing it to distort. This house is a resin-based house with plastic accents. It's not porcelain, so it's going to be more susceptible to heat distortion. So if you do use heat, use it at a lower temperature. It wouldn't exceed boiling water temperature, 212 Fahrenheit or 100 Celsius or centigrade. And I wouldn't put it for long periods of time, because that's still hot enough to distort the plastic and start to cause the resin to malform or deform. So the hot glue is coming out. See if I got enough of it to... Yeah, there we go. So I did get enough of it on this edge to get it to pop. Get the glue out of where the wire for the light is. Now I'm going to assume the mechanism just goes straight up the center and connects with everything. And we'll find out hopefully here in just a moment. Alright, all the glue is broke free. I'm going to take a peek inside to see what's holding it up. And it might be the reason it has that plastic access door. And that's why it has. So the access door has the speaker, and looking through the pried edge, these two screws screw into a boss. I'm wondering if they're holding it on, or if there's just some other glue I can't see. Like right here. Yeah, stuff like that. There we go. Yeah, it's just the glue. It's got a really large lip, and they got the glue smeared in pretty deep. Okay, so here's the drive mechanism. And tucked way up inside is the circuitry. So let me get this up close and personal. You can see in there we have this board right here has the blob chip, so that's the main circuit board. This board over here is just a light circuit board. It actually has a whole bunch of pins that would be used for other accessories, so it's a generic transfer board. It sends power in and then it transfers it out to other parts of the unit. I've seen a few other pieces with these, but this one's actually pretty large. It has 10 places for auxiliary stuff, and it's only using 2. Let's see, this thin red and black wire is the motor. This thicker red and gray wire is the light. That's why all these down here are gray and red. They're all the lights. And looking in, I don't see anything shorted out. There's no smoked areas. There's no burns. So I'm thinking it's probably just a bad motor. But we're going to try it again now that it's open and see if we can get any humming or anything out of it. Yeah, did you see a flash? So we got a bad component. The switch works fine. The beeping is telling me that the 4.5 volts has exceeded over 2 amps of draw, which your Lemax heads usually are 1 amp or 1000 milliamps and less, which is why it trips everything out and causes problems. So I'm going to see if the motor can be unplugged. That's, like I said, 90% of the time that's the cause. I might see if I can get the circuit board to pop out and get a better view at it too. And if it is the motor, it's a standard hobby motor. I've talked about it in a few other videos, probably most of them, that it's a standard 3 volt style motor that has a range of 3 volts to 9 volts on most of them. You can get them online. They're just little pancake hobby motors, and it's also what spins your disc and your DVD player and your CD player. They're all pretty much the same. The difference is the thickness. This one's rather nice. This one actually has a part number. A lot of the stuff from Lemax does not. And this one is a F1440. So if you're trying to find a new motor for this, search for the part number F1440 or cross-reference it to something that's similar. Only thing that really matters is the voltage. The voltage range is important. Alright, this circuit board is really glued in. They did a good job. This is probably one of the better glue jobs I've seen on these houses. It didn't skimp. A lot of times the glue is either very sparing or it's very poorly applied. I'm actually pretty surprised. Whoever worked on this one didn't miss gluing day. How can we get that guy out? Yes, I'm using a medical tool. They work really good for things like this. I can keep constant pressure on what I'm doing. There's one glob of glue way up in there. It's holding me back. Let's see if I can get it to break out. Got it. Gluing this back together is going to be kind of a pain, but we'll see what can be done. When I was looking up inside, I noticed there's a lot of this black cable that's twisted in there. I know why now. It's so when they did this outside the house, they could twist it and shove it in. So here's our circuit boards. So let me get it close to the camera again so you all can see what it looks like. This is the distribution board. You can see they're labeled P1 through 10, and they're only using 2, which are the lights up on the top. It's a really large board for such a very limited amount of use. This guy right here is your main distribution board with your blob chip, which is this piece right there that's pointing straight up at the camera. And then if you look at the back side of this guy, I was grabbing with the, I forgot what they're called, but they're for like clamping off veins and arteries. I was grabbing over here where the screw holes are because I didn't want to hit the copper pads, just in case there was something I couldn't see. This has a lot of discrete components, all those itty bitty little guys, and this itty bitty little chip, if it's like most Lemax, this is your amplifier chip for your speaker. You got capacitors and resistors in these little small chips and a couple of diodes here, and you got a triac or a diode there. So, but looking at this plug all the way at the top that I couldn't get to is the motor right there. So I'm going to unplug that one and test it. 99% of the time your LED lights will not cause a short that will stop everything from working. The LED will usually just burn or pop open, and then it quits, well, that light quits working. It needs something with a good draw on it to usually short out or stop the power supply from functioning. So I now have the motor unplugged. I'm just going to untwist the wire and pull it out. So the reason it's all twisted is because they glued it together, twisted it so this shaft wouldn't catch anything, and then glued everything to the outside edges of the house, which is why if you look through the windows you can see the wires. It's because everything has to be out of the rotating parts path. Since this is the only Witches Tower I've ever worked on, whoever put this together took the time to make sure that everything was clear and free and enough glue that when it dries out there's hopefully enough to hold it so it doesn't interfere with the mechanism. There we go. So let's plug it back in and see if the lights function. Because technically everything should start working except for the spinning, well, this part. There you go. If you ever have a unit that dies completely, just stops working, it flashes every once in a while, flickers, or makes your power supplies get hot, it's usually the motor, especially if it's animatronic. If it's animatronic, another thing you can do, and I've showed this on the Ghost Around and the Roundup, since it's the one that rotates and lifts, this track, while you turn on the power, if you can rotate this track and the lights start to get on or flicker or get brighter, it's the motor. So this needs a motor, and of course the screws for the motor are on the bottom, so you have to take most of this gear assembly apart. Very common, which is okay. We'll have a chance to check the belt, we'll check the drives, I'll check that 10-tooth, which is notorious for cracking. You know, the whole thing. We'll give it a thorough makeover. We'll wipe off any excessive lube around the motor, because that's what kills them. Yes, they do die on their own, just from use and age, but the biggest cause I see is failure is the lubrication. Electric motors generally don't need to be lubricated. Belt and pulley look good. Belt doesn't even really have much of a hump in it. If you let your belt sit for a long time, the belt wants to form into this teardrop shape. So when you rotate it, you'll get this little piece that protrudes out from the tightness of the pulley. It has a very small one, but it's not too bad. That's usually when the belt starts to vulcanize into position. I'm going to move this slightly out of the way. Make a little room. There's two really small screws right here for the motor. Don't lose them. They're kind of a pain to replace. You think, oh, I just pull the motor out. No, it's going to hit this gear here. So let's see how this thing comes apart, because I don't know if you've noticed, there's no screws anywhere on this other than the two screws that held it down and the two screws that held the motor in. So this looks like it's a press fit, and it is. This is a finger. This is a finger. So there's 4 fingers. If I do it from the top, you can see the notches. It's a plate that clamps over and it covers the other screws. This plate is probably an alignment guide for the drive. On there pretty good. Okay, that's one. I'm using the edge of the blade just to get some leverage because I can't fit my fat fingers between the gear. Ow, that finger snapped off. Between the gear and the finger. Wasn't my intention to have that finger break. And then there's the screws. What you can do if you take yours apart and one of the fingers snaps, or 2 or 3 or all 4, is take some very thin layer of hot glue or rubber contact cement. Get it on this flat plate. Do not get it in the holes where the mechanism spins, and then you can glue it on. Hot glue and rubber contact cement can be removed, whereas if you use super glue, yeah, you're not going to get it back off in one piece. So, alright, on this side we have the main gear that drives the shaft. It looks okay. There's a little bushing in this for the alignment of this gear down here, which is the 10-tooth. The 10-tooth is turning black, which is usually a sign of when they crack, I don't know why they always turn black. But it's always a sign that it's starting to go. Alright, here's the bad motor. Let's just take a gander at all the teeth. Everything looks good. I might replace this 10 tooth just because it not only is it turning black, it's got a heck of a wear groove cut into the teeth where it's touching this gear. Most likely reason why is the pulley is under tension, so the pulley isn't going straight up and down, it's trying to cock at an angle, which is pushing this 10 tooth into the gear, causing excessive stress. That's usually why they crack. It's not cracked, but instead of the tooth being nice and smooth, it has a little notch in it from the teeth of the other gear. The other gear looks completely fine. It's also got the black residue on it from the little gear. So I'll go ahead and pop that guy off and replace it as well. But the main thing is we got to fix this or replace this motor. So you can look up the F1440-R is the full part number. It's also known as a 300 CA, which is actually the most common designation, and that's how you're probably going to find them online. 300 CA motors, like I said, are a dime a dozen. You can get them on most consumer electronics if you strip them, part them, etc. And yeah. So here's one. It has my fingers are greasy if you can't tell. It has a different part number. This one is a BCZ 3B05, but it's the same motor. And just to show that it does function, I'm sure you can hear that. That's at 4.5 volts. I'm going to drop it down to 3 volts because a lot of times they resist the motor to slow it. You can hear it, it still works. So this motor, I believe it came out of the drive for a VCR. So if I have something that's to part out any of the components, I've been doing that forever. It makes things cheaper. And if you go online, these little 300 CA style motors, usually you have to buy them in a 12 pack or a 16 pack because it's not cost effective to send one. So I just part them out, saves time and money. And this, I think, is a 10 tooth. 1, 2, 3, 4, 5, 6. No, this little gear is not a 10 tooth. This little gear is a 14 tooth. So we're going to set that aside so we don't accidentally pop that one off and replace it. As far as the pulley goes, just carefully get under the bottom lip. You can see there's a little tapered section, and pull it up. You don't want to put pressure on this bottom edge of the V, because if you snap it off, then you have to replace the pulley. The kit that comes from Amazon does have this pulley in it. The Akui kit that I've shown in a couple other videos. So if you do break it, you can get that kit for it's like 10 bucks. Nice thing is all the 300 CA motors have the same diameter armature, so you can just swap the tip over, or the pulley over onto the tip, the shaft, the armature, whatever you want to refer to it as. But I'm going to have to cut this wire and solder it to these so I can plug it back into the circuit board, because I also not only need the connector, I need the length. So I can twist it all back up and push it inside with some hot glue. So I am going to cut it off right above where the hot glue smear is. Hopefully see that right there. These motors do not care about polarity, but your drive does. Meaning, if you solder the wires on, you know, I do brown to black and red to the cream color, just not quite white. If this spins the wrong way, these witches are going to be walking backwards. And as much as moonwalking witches might be really cool, that's not what it's intended to do. So, I'm going to reassemble this and then twist the wires on and test it. If they start spinning the wrong direction, I'm going to switch the wires. And how I'm going to tell if they're moving the wrong way is the direction of this armature spins. This kind of looks like it's a square. It has to spin in one direction. And if it's spinning in the backwards direction, of course, then I'll just switch the wires around. So, let's see, before I forget, get this gear off as well. Same thing, get underneath the edge, pry it up. If you get 45-degree pliers from your hobby store, works really easy. And that's the difference between a 14 tooth and a 10 tooth. I don't know if you can really tell the difference. You can see the teeth are closer together on the 14 tooth, and there's more of them. So I just got to remember where I put my gears. So, since my bucket of gears is missing, it's probably sitting with the Gemmy project I'm working on. I'm just going to open another one of these animatronic repair kits from Skull Crane Animatronics. They sell these for the Gemmy products, but the parts in here, same parts as in this. So, and this little baggie is $10. And this little baggie, in case you didn't see my Gemmy video, because it may not interest you because you don't have those products, has an 8 tooth, a 9 tooth, the ever common failure 10 tooth, and then it has those pulleys that I was telling you about, and then it has belts, little itty bitty drive belts. So, which is this guy right here. And because these break-in are so hard to find, you have for $10 15 pieces, I believe it says, to repair your Gemmy products, but it also, yeah, 15 total pieces. But it also repairs these. So, people ask where you can get them. Just go to Skull Crane, spelled with a K. There. Animatronics. And you can get these animatronic repair starter kits. I bought them because I've been fixing some Gemmy products, which are those 6-foot tall figures that you see at Halloween or Christmas that jump up and do things. And I bought a whole bunch of the kits because their necks break. And when the necks break, I have 10-tooth gears, I have 12-tooth gears, I have 8-tooth gears. But I don't have any 9-tooth gears, and they're kind of hard to find. And also finding the drive belts, sometimes those are hard to find too. So I figured for $10 I'd buy a few of them and, well, use them. So push on the new gear. They are tight, so it's not like it's going to just slide on because they are pressed on gears. There we go. There you go. So, gear is in. gear fall out. I just dropped the big gears. That's that one. Give me 1 second to go get that other gear. I'm going to get that gear and screw this together, and we're going to test it. Be right back. Okay, I got the gear, put it back together. So it's all assembled. Turn it on. You might be able to see the teeth moving. The shaft is rotating counterclockwise, which is the rotation of the witches. The white wire is the hot, or the cream. The brown wire is the ground, or negative. And that's at 4.5 volts that this thing is spinning. I'm holding it by the shaft so you can see it rotate on the bottom. Also, you should be able to see all these gears turning. There we go. But one thing I did want to point out is if you have this one has some really tight tolerances. It's really hard to tell, but that upper gear that drives the shaft, sitting on top of its spacers, has literally a sheet of paper's thickness between the motor and that gear. The tolerances on this entire gearbox is insanely tight. Before I put this in to show you it works, I double checked it with this one to see if they're the exact same height, and that tolerance is amazing. It doesn't touch the armature back, nor does it touch the casing. It is really close. So whoever designed this made sure it was as compact as possible, and if you replace it, you have to make sure the motor is the exact same height, maybe a hair smaller, because you can get these motors in a slightly different height. I have smaller, thinner versions, pancake style. So, very important that you're aware of the height of your motor's casing in relationship to the main drive gear that drives the armature that makes everything inside spin. So, next part is going to be soldering these together. So I'm going to turn on the soldering iron. And we're going to want to put some heat shrink over these. So I'm trying to find some really small heat shrink. So once they're soldered, they won't touch anything. Potentially one of the discrete components on the circuit board and short out. So we are going to try and make this as secure as possible. So the hardest part, I think, of this whole process is going to be gluing those circuit boards back in, because they're so high up there and the glue has to be really hot and then it has to be held in place. So I'll probably tip it up on its end and support it and just pour glue down inside. Not pour, but take the glue gun, get it down inside, and just make a puddle that I can push the boards into, and then try and use like a screwdriver or something to keep the puddle from migrating into the mechanism. I have no idea how they did it at the factory, but this is a very tight toleranced piece. But once you get that bottom off, it's actually pretty easy to fix at home. As far as if you break a gear, break the motor. If you break the speaker, meaning you pop it and it's all staticky, and you need a new speaker, it's really easy to access, but you're going to have to try and match up the size because that's a very small speaker. It's actually even small for Lemax standards. So. Alright, so there's the two soldered wires showing you that they hold. Throwing the weight of the mechanism. Slide over the heat shrink, which hopefully will fit, meaning that the solder isn't too fat for the heat shrink, which it's not. To ensure, you can use a heat gun, but instead of waiting for it to turn on, I'm just going to use a lighter real quick. It's just faster and smellier. Alright, so now we're going to use it under its own power. So plug this back into the motor spot. So, and I'm going to use the power supply, the actual factory one. Like so. I'm going to lift it because if not, these pulleys will spin on here and I'll try and walk it away. There you go. It's not shorting it out anymore. And it is rotating. So it is good. Now I just need to glue it all back together, put a new bottom on it so it's you know, a rubber mat. Scrape the rest of this one off, and then excuse me, show you what it looks like complete so you can see that it actually is moving everything inside. So to save on time, the reassembly is, well, it's the opposite of the disassembly. Glue the circuitry up inside, push the mechanism back in, screw it to the base first, of course. Try and line it up with the hole in the, that's right about here, right where the edge of the camera is where this fits in. Because it's a square hole, you might have to turn this base until it drops in and then glue it back down. It's just like when you're putting the gears in. I showed it in the past, but when I had to put the gearbox in, it wouldn't close. And it's because the teeth didn't line up. You just rotate the gear a little bit and then it shuts on its own. You can screw it back together. Don't force it. You don't want to break the teeth off the gears, especially if you just replace the gear. It kind of defeated the whole purpose. So, but this is the repaired setup with a gear that was worn and a new motor which was shorted out. The grease on this plate where the motor is, I wiped off. I did clean and re-lubricate the shaft for this gear and the very edge where the little gear part of it is, since when it hit the floor it picked up of course debris, dust, etc. So if you drop the gears, clean them. You don't want that stuff inside the teeth. It can cause it to bind, which eventually will put stress on the plastic and cause it to break. So I'm going to now heat up the glue gun. So I get that circuitry put back in and then clean off the rest of this and show you it completed with the witches spinning up here on this ledge right there. Since I can't show you the top because it didn't come with the witches to rotate. When stuff is sent in, I don't need all the parts. I just need the parts to make it work so I can make sure it functions correctly. The witches are visual that you would see, but they're on the same drive mechanism as the ones on the plate, so it's not required. But yeah, bear with me for a few moments. I'll pause real fast and be back shortly. Okay, here's the Witches Tower back together, and to show you, there you go, see it's rotating. I haven't done the bottom yet, but you've all seen a couple of the bottoms I've done. So it's all glued back together, put back in, it works. So, some points when you put this back together if you ever take yours apart. It is a pain to line that shaft up with that square boss that's about right here on the inside. So, I understand partially why they use these hollow windows. One, it saves money. Two, if you use a flashlight, you know, such as this, and you just get a little bit of it to cover the window, you can actually see the shaft and the white boss that it fits into. So, holding it upside down, and I actually, with one hand and holding the flashlight with my fingers of that hand, I was able to keep maneuvering this bottom base until it slid into that boss. If you're having a problem, you can just turn this on while you're doing it carefully. So when it drops in, as it's spinning, it'll line itself up with the hole. The other way is to put this where it's pressing against the plastic and then rotate this disc until it drops in. Basically, it's a square hole and a square peg, and if you're out of alignment, it's not going to drop in. It's just, you know, common way it works. Some little points that I saw on this while I was putting it back together. It's got a really good paint job. I know he didn't send the witches, which is fine. I didn't need them. But one thing I don't like is, and I would fix it if it was my piece, is some of my stuff is up high, which means that you're looking at it from an angle like this. I don't like the fact that this isn't painted. It's just a personal thing. If you look at it from the bottom edge, every flat spot is painted except for this takeoff ramp. If it was mine, I would try and color match some acrylic paint and paint the bottom so it's not white. But other than that, it's a nice tower. I've never owned one. I'm not into the witch theme, but it's a resin with plastic inlay, which I know some people don't like the resin and the plastics, but it makes it easier to repair, which means you get more life out of your product. It's mostly resin. You got plastic windows that are all glued in, plastic railing that's glued on, a plastic base, of course. So, plastic brooms. But other than that, it's a nice piece. It's fully functional again. It works. You can see them walking around. They're going in the right direction. We don't have a moonwalking set of witches or cats. So, here she be. We'll leave with this thing in the dark so you can see what it looks like in case you haven't seen one. Again, minus the witches that are not in the box. So there it is from the top. And there you go. So, thank you for watching. Hopefully this helps with your Witches Tower. Until the next one, have a good one.